talked about zeros of the polynomial. When we talked about the zeros of a polynomial, it just makes whatever makes the function equal to 0. So whatever your function, what makes your function equal to 0, that's your zero of the polynomial. Let's take a look at one of the bottom ones down here. Go ahead and determine the zero of the polynomial here. We'll just do the first one. Let's do the second one here. That'll be more of a challenge. Let's find the zeros of this polynomial. Well, if I'm trying to find the zeros of the polynomial, I'm looking to see what makes our function equal to 0. So we set our function equal to 0, and we solve. Well, what you may want to do is think about how do I go about solving these types of things. Maybe look for a greatest common factor first. Can you pull out a greatest common factor? Once we pull out the greatest common factor, then look to factor it down. You have a trinomial factors into two binomials. Check your answer with somebody around you. First thing we can do, we can factor out the x. We have a common factor, so we have a greatest common factor x that we can factor out. So we have an x squared plus 4x minus 5 is equal to 0. And once again, we are just using our algebraic skills here. What's our algebraic skills in regards to factoring? Well, we factor out a greatest common factor first. Factor out a greatest common factor first. Then we look to factor down. Jordan, what does that factor down to?
X minus 1, x plus 5.
Okay, now using the multiplication property of 0. The multiplication property is 0. If I have things multiplied together equal 0, one of those factors have to be equal to 0. So x could equal 0, x minus 1 could equal 0, or x plus 5 could equal 0. So here we get x is equal to 1, x is equal to negative 5. So we have three solutions here, 0, 1, and negative 5. Now, one thing to note here. Our largest degree term is 3, so the degree of our factor or our polynomial is a value of 3. the degree of the polynomial, if it's in one variable, will also tell you the number of solutions. It will tell us the number of possible solutions. But they can either be real or imaginary. Either real or imaginary. Multiplicity of a function. Multiplicity of a function. When you deal with the multiplicity of a function. No definition there. When you deal with the multiplicity of a function, it is it's the number of times a solution is repeated. The number of times a solution is repeated. Now, when I'm talking about a solution, I'm also talking about a zero is repeated. If we take a look at the polynomial here, we have x minus 5 quantity squared, x minus 3, and x plus 7 quantity cubed. So by definition of exponent, this is x plus 5 times x plus 5 times x minus 3 times x plus 7 times x plus 7 times x plus 7 is equal to 0. That's just by definition what do we have of an exponent. Now, utilizing our multiplication property of 0. Our multiplication property of 0 is if I have a series of things being multiplied together, each one of those things could equal 0. So x plus 5 could equal 0, x plus 5 could equal 0, x minus 3 could equal 0, x plus 7 could equal 0, x plus 7 could equal 0, x plus 7 could equal 0. So here we get x is equal to negative 5, x is equal to negative 5, x would equal 3, x would equal negative 7, x would equal negative 7, x would equal negative 7. Well, we have a lot of repetition there, a lot of redundance. That's why we utilize, this is where we utilize the idea of a multiplicity. We have x is equal to negative 5 twice. So the number of times it is repeated, that is its multiplicity. So we have x is equal to negative 5, multiplicity of 2. Here we have x is equal to 3. Here we have x is equal to negative 7. Multiplicity of 3. It just tells you the number of times that solution is repeated. When you have a multiplicity, it's the repetition of solutions. My next question is then, what would be a possible graph to this? We are finding the zeros of a polynomial. The zeros. This is also called the x-intercepts. So when you're talking about the idea of a function, an algebraic idea, this is the zeros of the function. When you take a look at this in the graphing realm then, it changes from the zeros of the function, that's in the algebraic world, into a graphing world. It turns into their x-intercepts. So what we have here is we also have x-intercepts at -5, and at 3, and at -7. Why? Because those are the zeros of the polynomial, which is also the same as the x-intercepts. We can also find the y-intercept. And that is where x is equal to 0. So if I put 0 into my function here, we have 0 plus 5 squared, 0 minus 3, and 0 plus 7 cubed. Well, this just turns into 5 squared times -3 times 7 cubed, which we can clickety-clack through our calculator. And you'll get sort of a large number. Debbie, what do you come up with?
365.
I'm sorry, what?
365.
365? Yes, no, maybe so? 5 squared times -3 times 7 cubed.
Oh, I added.
So that's sort of small.
Negative 25,725.
-25,000 what?
725.
725? That's a little better. Now, I want to get a possible graph here. Going down to -25,725 is sort of unrealistic with our graphing. I wouldn't suggest doing that. So what we can do with this is we put 2 little squiggles in there. What that means is you have a little break in your graph. And that allows me to then just write a hash down here at -25,725 for my x-intercepts, or for my y-intercepts. What was that? Huh? Was that outside there? Oh. Now, my x-intercepts I should be able to graph. So So I'm going to have x-intercepts at -5, -7, and a value of 3. Now we're trying to just get a possible graph here. And this gives me an indication of points I have to go through. I'm going to cross my x-axis at these points. I'm going to cross my y-axis down here. So my middle part of my graph, I'm going to take it and bring it up through. That allows me to then continue my graph. Who knows how high this goes? But this is just a possible graph. It's a possible set of solutions to the polynomial we have there. I mean, there's a good chance it probably goes a little bit higher, but who knows? Now, do I have to write out each one of these to tell me what my multiplicity is? I have x plus 5 quantity squared. That tells me how many x plus 5s I have, which should also tell me what my multiplicity is. I have x plus 7 cubed. That means I have 3x plus 7s, which will also tell me my multiplicity. So my exponent should tell me what my multiplicity is. So you now go ahead, write your solutions here in the multiplicity, and then get a possible graph down. Find your x and y intercepts. And get a possible graph down. Our zeros here in multiplicity, Marissa, what do you have?
X plus 8 multiplicity 5.
What's my solutions?
Negative 1, 8, negative 4,
And multiplicities?
5, 4, 8, and 3 for negative 4.
Okay, so it just tells us the number of times that we have as a root up here. That means our x-intercepts will be our x-intercepts, Preston.
Intercepts are -1, -4.
Our y-intercept. Isaac, what's our y-intercept come down to?
I got negative 200, negative 2097152.
Negative, whoopsie. 2091752. So we have 2,091,752. And we can find that by putting 0 in. So we have 1 times negative 8 to the 5th times 4 cubed. Gives us that? You good with that?
Just the 7 and the 1 you said.
Huh?
The 7 and the 1 you, like
So
2 million.
these two need to be 7.
Yeah.
7152. Like that. Sorry, my calculator's not working well today. Didn't quite get that. And then once again, a possible graph. Make sure you label your axes. We have -1 and 8, -4 and 8. And we can break our graph here and give us our -2,097,152. -4, -1, and 8 is my y-intercept, so we need to make sure we cover our y-intercept and also our x-intercepts, so we can go down, up through, up and around. Possible graph. Questions? Now, I gave you the worksheet on Friday, said if you want to start working on some of the or some of the problems on Friday, that's fine. The completion of the worksheet will be your homework for today. So whatever you did not complete, do you have any questions right now on any of the problems from the worksheet? Yeah.
I don't understand how we can factor down the 7.
How to factor down 7.
Like, once you take out the greatest common factor, I don't understand how to reduce it.
Problem number 7, 2. Okay, what'd you take it factor out?
2x.
2x. Okay, so if we take a look at 7, we have p of x is 2x cubed plus 6x squared minus 4. And we're trying to get it equal to 0. So we factor out a 2x, we're left with x squared plus 3x. Oops. Plus 3x minus 2 equal to 0. Okay, well, if that was a plus 2, that would work. But we have a minus 2, not factorable.
So it's just an empty set.
Now, how else do we solve them? It's not factorable. The quadratic formula, the quadratic formula, the quadratic formula, the quadratic formula, which is negative b plus or minus square root of b squared minus 4ac over 2a over 2a, over 2a, over 2a. Any other questions? Sorry. Just breaks me into song. I know. Don't give up the daytime job. I get it. I get it. Don't give up the daytime job.
Was it 6 tonight?
It was supposed to be 6, it's gonna be at 7 now. Because we eliminated volleyball for tonight and moving that into next week.
Okay, I just wanted to make sure, because I wasn't thinking.
Yeah.
I know you said it, but I wasn't.
Yep, starting at 7.
Thank you.
Any other questions? Alright, you have about 15 minutes, the rest of the time is yours.